Shoo. Hey there. All right, we're talking inverse functions, and specifically, given a function, find its inverse. Now, the general mechanical way to do it is to switch x and y and then solve for y. So how to find the inverse function. This is one mechanical way to do it. This video isn't so much about the proof of it, it's just about how do we do it. So here's our first function. And let's see, f of x equals 3/5 x minus 1. Well, there's no y here, so let's put it in. Great. We have a y now. Now the rules say to switch x and y and then solve for y. Okay, so now it's no longer the same function. I'm going to put a little line here to say, whoop, they're not the same function anymore. We swapped the x and y. But now we need to solve for y. So now we do inverse operations to get that. So this is all one term, so we need to move this term over. So we're going to add 1. So we get x plus 1 is 3/5 y. And then we're going to divide by 3/5. I'm going to write that in a different color so we can see, just so you can visualize that. Here's the big vinculum, and then the 3/5. And we're going to do it to both sides. Because then this divides out to 1. And then now we have x plus 1 all over 3/5, which looks strange. And it's a good practice to just understand how to work with fractions, especially when you're multiplying and dividing. So when we're dividing by a fraction, we multiply by the reciprocal. So we get 5 times x plus 1 divided by 3 is y. And we'll go one step further, distribute that 5 into our parentheses. Great, that's it. We've solved for y in the inverse. Little note on notation. F with this little -1 here means inverse. So this just says, here's the function f. That's its inverse, and that's what it is. And it's always good to double check that it truly is the inverse. And what does the inverse function do? It undoes the function. So here we have this function. So if we substitute in, let's pick a nice number to work with here. Let's say we do, you know what? I need to fix something here. Just a second. All right, there we go. I just had to move something over. Because I wanted to do, and it's important for us to always feel we can do this, is to check to make sure it works. So if we substitute a value in for here, we get an output. If we take that same output into the inverse function, we should come back right where we started. So let me show you what I mean. Let's pick a number that's easy to work with, f of 5. So 5 is the input. So let's see. 3/5 times 5 is just 3 minus 1. If I know my subtraction, that should give us 2. So that means when we input 5 into our function, we get 2. So now let's take that 2 and substitute it into our inverse function and see what we get. I was getting nervous. I just hope this works. All right, so let's see. 5 times 2 is 10. And 10 plus 5 is 15. And 15 over 3, oh, thank goodness, it's 5. So this is what an inverse function does. It undoes what the other function does. Input 5, we got out 2. In the inverse, we put in 2, we get out 5. Look at that. So I always recommend to check your work. All right, so now let's go over here. Let's look at this one. F of x. You know what? I'm going to change f to h, because we already have f over here. We don't want to get those mixed up. So h of x equals 7 minus square root the quantity 3 minus x. All right, so let's start on doing this. Let's switch x and y, and then solve for y. I'm just going to go ahead and do it in one fell swoop. So instead of rewriting it as y equals, I just know I can say h of x is the same as y, then just swap where the x and y would be. And just here I have that squiggle to denote the new, this is a separate function than the top function. That's what this line is. Here's our initial function. The inverse is all down here. So now we solve for y. Let's see. I want to get this by itself, but I also want it to be positive. I'm going to, you know what, I'll just do one thing at a time. I'm going to subtract 7 from both sides. There's different methods, but we'll just go with this one. That root 3 minus y is still negative, so it's right there. But we need to get it positive, so now I'm going to multiply everything by a negative 1. So that negative 1 is going to get multiplied into every single term in our equation. Negative 1 times x is negative x. Negative 1 times negative 7 is positive 7 equals negative 1 times the negative root business, which is positive root 3 minus y. Great, we are almost there. We're going to square this guy. And we're going to square both sides. I'm going to square both sides here. Let's see. So then what we're going to get is 3 minus y, because the square undoes the square root. And then here we get a squared binomial. So all right, so there's our squared binomial. Now I'm going to distribute in here. Let's see. I'm going to FOIL this thing out. Let's see. Negative x times negative x is positive x squared. Negative x times 7 is minus 7x. 7 times negative x is negative 7. 7 times 7 is plus 49. Let's see. We can combine things now. Let's see. X squared minus 14x plus 4 is 3 minus y. Great, we're looking pretty good. We're almost done. Let's see, I'm going to subtract the 3 over. Minus 3, 4 minus 49. Whoa there, come on, Southam. 49 less 3 is plus 46, negative y. We're almost done. Let's see. We are going to multiply everything here by negative 1 again. And basically what we're going to do is all the signs are going to swap. So we'll go up here. Whoop. I'm just going to show you. Again, this is a video about some of the computation methods, so this is what we're doing. We're taking this whole thing and multiplying it by negative 1, so then that negative 1 gets distributed in to every single term. Negative 1x times x squared, just negative x squared. Negative 1 times negative 14x is plus 14x. Negative 1 times 46, negative 46. And then negative 1 times negative y is y. Bink, and there we go. That's our inverse function. But because we're talking inverses, let's not stop there. Let's actually call it what it is. It's not y. It is f inverse. Oh, h inverse, pardon me. that. There we go.